We've discussed looking at rational polynomials to look at dividing out terms as we take those limits, and that's not so hard to do, but a way that is kind of a shortcut for rational polynomials follows this algorithm. It says that if I have some function which is some polynomial on top divided by some polynomial on bottom, then there's a sort of a trick to getting the value of these limits. The first step is to rewrite both of them as a same degree polynomial. So if this was a third degree and this was a second degree, you write them both like they're a third degree polynomial, and you use a leading zero as needed. So you would write like something x cubed over 0x cubed. And then what you're going to do is we're going to divide the leading coefficients. So whatever those two leading numbers are with the same degree, we're going to find that fraction. And then finally, if that fraction is 0 over something, the limit is 0. If it's a number divided by a number, the limit is that number. Now notice that these two are technically the same thing, but sometimes it's helpful to break that out as a separate case. And then finally, if it's a number divided by 0, we're going to have to be a little more careful because you might end up at positive infinity or you might end up at negative infinity, depending on what the circumstances of the situation are. So you have to, in this particular case, you just need to be very careful. Alright, so taking a look here, this is our first example. We have 4x squared plus 6 over negative x cubed minus 1. So what we're going to do is we're going to rewrite that. So the largest degree here is 3. So we're going to say 0x cubed plus 4x squared plus 0x plus 6 over negative 1x cubed plus 0x squared plus 0x minus 1. You don't really have to write all this here, but all you're going to do, that's step 1. Step 2 is to look at that fraction, and that's 0 over 1, so that's a finite number over a finite number there, or so it's 0, or it's not 0 on the bottom. That's really the case you have to worry about. And so that tells me that my answer to the limit is just 0. So that's simple enough, right? Let's try to apply that again. So in this case, they're both third degree polynomials. So you get negative 7x cubed plus 0x squared plus x plus 0 over 2x cubed minus 4x squared plus 0x plus 1. You look at that fraction, and the answer is negative 7 halves. Simple enough. The next one is here. This limit goes to positive infinity. 3 minus 8x over 3x cubed. Okay, so this is x cubed is the largest one here. So that gives me a 0 because I'm just, again, you rewrite this as a third degree polynomial. Whoops, that should be a cubed there. So it's 0 over 3. So again, pretty straightforward. This one's going to be a little more complicated. So if I had, and so let's do one last one here. Let's do the same problem, but this is x to the 5th. Let's do those problems together, because I want to show the difference. All right. So this is, the limit is x goes to negative infinity of 1x to the 4th plus 0x cubed plus 0x squared plus 0x plus 6 all over 0x to the 4th plus 1x cubed plus 0x squared plus 0x minus 8. So you have this 1 over 0. So you might say, okay, 1 over 0, that's infinity. But it doesn't work out like that. The reason why it doesn't work out like that is because you have to be careful with how you divide. So in this particular case, what you're going to know, what you want to take note of is the fact that the difference in these exponents is 1. So it's a fourth versus a cubed. And that matters because I'm going to rewrite this sort of the other way that we used to do it, or the way we did in the previous section, where we would say that was the limit as x approaches negative infinity of, if I factor out an x to the fourth from everything, let me factor out an x to the fourth. What you're going to get is, no, let me factor out an x cubed. I know that's going to sound weird, but let me factor out an x cubed. You're going to get x plus 6 over x cubed over 1 minus 8 over x cubed. So I'm going to separate that into two limits. X over 1 minus 8 x cubed plus 6 over x cubed 1 minus 8 over x cubed. I'm going to separate those two. So in this particular case, when I take x to infinity, this gets really large, so it just drives it down to 0. And then on top, this little subfraction also drives down to 0. So that's going to clearly go to 0. But in this particular case, that's going to drive to 0, that 8 over x cubed, right? Because that x cubed is going to get huge, so 8 over x cubed is going to go to 0. So we have 1 minus 0. But then you have this x, but it's going to negative infinity. So in this particular case, x is going to negative infinity. It's not going to positive infinity, it's going to negative infinity. So that tells me the limit's actually negative infinity. So that's a little more challenging. The reason why I say that is because you could do the same process here for this one and you get 1 over 0. But what you're going to find in this particular case, so again, let's factor out an x cubed. So we'll get the limit as x approaches negative infinity of x squared plus 6 over x cubed all over 1 minus 8 over x cubed. So then what you're going to find is this is going to go to 0, and this is going to go to 0. So you basically, it's going to be the same limit as x squared. But as x goes to negative infinity, x squared goes to positive infinity. So you have a difference there in terms of the outcome, even though in both cases the coefficient on top was larger. So you have to be careful with that. And it would be further complicated if this was like a -3 or something like that. So in the case where the coefficient on top is larger, sometimes it helps to fall back to the old style, but there's really a few tricks here. And one is that if the degree is slightly larger, it really just has to do with the coefficient in front here, and the sign on the limit. So basically you take the sign on the limit, and then you take the sign on the coefficient, multiply them together, and that tells you your type of infinity. And in this case, but if the if these are a difference of 2 or 4 or 6 or something like that, if it's an odd difference, then it's only this coefficient which makes a difference. This coefficient doesn't make a difference because, again, that squared always makes sure it goes toward, it's basically going towards positive infinity. So I know that, I get it, it's complicated. That's why these two cases are really your best bet. In this particular case, you're going to have to be a little more clever, but once you do this a good bit of times, you'll start to get that intuition, so you really don't have to overthink it.